Hello, my name is Kuncheng. This is a homework 3, problem 1, presentation for the course probability and stochastic process. Let's do the question. The first question is find the B so that probability x equal to k represents a probability mass function. We know the property of the probability mass function is the sum of the probability equal to 1. You see that? And if we want to get a B, so we need to satisfy these properties. Also, let's do some discussion for the normal mathematics. We know we have the function like the geometric progress function, and we know the ratio is p and the first number is 1 where k equal to 0, and we plug in the ratio and the first number and we get 1 minus p k squared over 1 minus p. Because we know the probability greater than 0 and less than 1, so if k is infinite, so the pk squared is 0, and we got the sum of the pk is 1 over 1 minus p. And next we can use differentiate function, like because you know this function we use d over dp, like we can get the sum of k times probability k minus 1 square and equal 1 over 1 minus p square. And if we times p and we get sum of kp k square and is p over 1 minus p square. And similarly we can get sum of the k square p k minus 1 square. We also differentiating both sides with respect to p, and we get sum of k square p k square, and we got the function. And similarly we have the one more, like we can get the sum of the k3 square times p k minus 1 square equal to that one. And then we can do the question. If we want to get B and also satisfy the probability mass function, and we can easily write to like here, and B k p k minus 1 square, and from k equal to 0 to the infinite and equal to 1. And we can use the function like here, this we got function, and we can get b times 1 over 1 minus p square equal to 1, and we get b equal 1 minus p square. That's the first question. And next we need to find energy. Find the energy. The energy is easy. We can use the energy function is get sum of the k equal to 0 to the infinite times k, and k times probability x equal to 0, and like that. and we can transfer to the k equal to 1 to the infinite, and plug in the probability function is b times k square, because we changed the 0 to 1. We have one more k square times p k minus 1 square. We just plug in the function, and we also use the function we get above is 1 minus 1 plus p over 1 minus p. Okay, that's the second one. And we have third question is, this one we can get more specific, like, because b equal to 1 minus p square, and we plug in this one, the sum of k equal to 1 to the infinite, and times k square times p k minus 1 square equal to 1 minus p third square, and this one is the 1 plus p. Here you can see here, yeah, this one, and b times 1 plus p and over 1 minus p 3 square, and you can get 1 plus p and 1 minus p. That's the second one. And let's do the third one. Is we need to find energy x squared equal to what? And for this one, we just plug in, like we have also we have sum k equal to 0 to infinite, and the plug in the function is the k square p equal to probability k equal to x equal to k, and plug in the function is sum of k0 to infinite, and we have a b, and because this one is x square, so k is square, so we have k square times k, oh sorry, this is 1 times k, and times p k minus 1 square, and we can use this function, and we got 1 plus 4p plus p square and 1 minus p 4 square, and also b equal to 1 minus p square, and plug in the energy x square equal to 1 minus p square and 1 plus 4p plus p square. So this one is the answer for this question, and we have the D. The fourth function, the fourth question is we need to get energy x square minus energy x. This one is so easy. We got the function of the energy x square here, and we also get energy x function here, and just minus them, like we have this one ngx squared plus 4p plus 4 p squared minus 1 plus p over 1 minus p, and calculate that, and like we have the for p, you know, because 1 minus p times 1 plus p equal to 1 plus p squared, and this one minus this one, and we get answer here. And for the last question is, we give the piece value is 1/3, and we need to get probability p equal to x, probability x equal to k, and in where x greater than 2 and less than 5. Also, for this one, we can easy to get a function, the p probability x equal to k, where x greater than 2 less than 5. The function we can, according to the lecture content, and we can get this one equal to probability x equal to k, and when x greater than 2 and less than 5, divide the probability x equal to k, the sum of k from 2 to 5. And because p equal to 1/3 and b equal to 1 minus p squared and equal to 4, divide 9, and we use this function p x equal to k, where x greater than 2 less than 5 equal to, like we can calculate here, is sum of 2 to 5, and b, we can plug in the function, is b is the 4 over 9, and times k, and times 1/3 k minus 1 square, and we have the probability x equal to k, and when x greater than 2 less than 5. And we can calculate here is from the 2, like we calculate is 8 minus 27 plus, that's k equal to 2 and k equal to 3, we can get 4 minus 27, and we can get one more is 15 to 7 times 3, not 3, sorry, actually I need to check. The number is times 9, and plus 20 over 81 times 9, not 15, 16, and we plug in the number here is b, this is b, and times plug in the function like times k, and also one more. That's a function for the probability, like calculate that is, that's the number of here, we just calculate the number is the four number, the sum of the four number, and we get the nominal is 4/9 times k times 1/3 k minus 1. That's the function for the probability, and where k from 2 to 5 and p equal to 0 otherwise. That's the problem 1 for the homework 3.